Hi, I'm Dana here. Today I'm going to present Kaggle Capstone Project that's outcome of Kaggle's 5 days agent intensive course, where I have mastered the concept like multi-agents, monitoring, evaluation, and deployment. So using these skills, I built MediSync Agent, a synchronizing AI for safer, smarter patient care. It's a production-ready healthcare coordination system under the Agents for Good track. So what is MediSync? It's a multi-agent healthcare coordination system that brings together a specialized AI agent to work in parallel for the optimal patient care. So the problem statement that I have here is hospital generates millions of discharge summaries daily, but they are unstructured and hard to review. This leads to costly risk of 20% of Medicare patients are readmitted within 30 days, costing around $26 billion annually. 67% of patients face medication discrepancies post-discharge, risking the dangerous drug interactions. So the core challenges are the informations are silo, a significant safety risk always exists, care coordinators are overwhelmed, and patients are unclear with the complex medical jargons. So, to overcome all these challenges, the solution that I have built is the MediSync agent. You will have a structured output of diagnosis and medication details, a safety layer that detects and flags the medication issues. A complex medical document will be turned into a simplified version. So, system successfully completes this entire workflow of the pipeline in 2.3 seconds. So, why multi-agent system? Because it mirrors and prevents the hospital workflow by assigning the specialized agent, analyzer, pharmacist, and care coordinator to distinguish their task. With the parallel processing and agent to agent collaboration, it reduces the response time from minutes to seconds while ensuring the accuracy and trust. So, this architecture is scalable, allowing the new agents like a lab results to plug in seamlessly without even retraining the model. So the core three agent that I have built here is analyzer agent, extract the structured patient data from the discharge summaries or the image file. The pharmacist agent safeguards against the drug interactions and dosage risk. The care coordinator agent delivers the personalized plain language guidance for patients. Together, they mirror real like a hospital workflows, working in parallel to reduce the response time and it will improve the safety. I do have an advanced infrastructure built in for this application, the A2A protocol, enabling the real-time agent collaboration through prioritized message queues and workflow correlations. And the MCP server that has a inbuilt custom tools. It will ensure that consistent access to the OCR and drug databases and guidance generations across the agents. And at the core, I have the patient knowledge graph, centralizes and tracks evolving patient data, enabling the context aware decision that drives safer, faster, and more of personalized care. I do have this patient pipeline that is built in. I will show you during the demo with the UI dashboard how these agents are coordinating, and then the patient results are getting reported in the dashboard. I do have that interactive dashboard as well in the Kaggle notebook for people to see and the judges to take a look at it with the dashboard details of the real-time metrics with the agent status card, how many patients has been analyzed and what are the number of medications that is being monitored for each patient, and the medication tab which will have a visual display of critical or major or minor drug interaction, a patient analysis tab where you can select the patient and run the multiple agent pipeline and see all the three agents how they are getting executed in the sequence, a chat tab which will have interactive patient support asking questions like when should I take medication and when is my next follow up, like that. A report tab will have a dashboard with a patient demographic interaction statistics, and you can even download the reports like a JSON or CSV or PDF format. So the conclusion that I have here is MediSync is a robust multi-agent medical intelligence system that extracts, analyzes, and explains the hospital discharge summaries. It showcases the real-world healthcare value, a strong agent-oriented structure, a clean modular design, a practical patient and the clinical benefits. Now let me quickly get into the Kaggle notebook. So this notebook will have all the details that I talked about with the problem statement solutions and the agent architecture and the MCP tool implementations. So step one, I'm importing all the required libraries and I'm installing all the required dependencies. And step three, I am cloning this GitHub repository in order to run the project. I'm setting up the API key in order to call the Gemini API model and configuring all the generative AI. The API is configured successfully here, and you can see the Gemini model has been called successfully. In the step 6, I am handling the data path, ensuring that all the input file that I have given, the discharge summary CSV file and the two image file has been uploaded correctly, and it is available before I run the pipeline or the workflow. Step 7, I am loading and inspecting the patient data. So here you can see the CSV file has been loaded. So this is just a preview of a few patient record from the CSV file with the patient demographic informations. And I'm importing all the required MediSync modules here. And I'm initializing the system. You can see all the agent that is getting initialized, and then it is getting ready to run the pipeline. Now here I'm running the complete agent pipeline. So for demo purpose, you could see the patient is selected, analyzer is extracting the patient data, that analysis is complete, and the pharmacist is analyzing the drug interaction, and the care coordinator is generating the patient guide with the requested questions. And step 10, I am displaying the results and the analysis with all the patient information and the diagnosis and the medication details and the follow-up appointment that is needed for the patient. The next step, I'm showing the OCR demo where I'm extracting the text from the medical images using the Gemini Vision API. You could see the image 1 and image 2 is extracting the text using the Gemini Vision API, and the OCR extraction is successful with a list of medication is given over here. The next step is where I have built the A2A protocol and all the custom inbuilt tool where I am calling for the agent to agent interaction. I have given all the details here. So there are three tools that I built here: extract medical text, which will extract the text from the medical images using the OCR, and analyzing the medications from the safety profile, and generate the personalized patient guidance and the response. And I have given the scenario like how all these three agents are interacting, and the details are getting shared between them. Next is about the comprehensive report for the patient that I have shown in the demo. You could see that all the details, that is something that you can readily download it in a JSON or a CSV or a PDF format. Next is the interactive dashboard. As I mentioned before, you could come here and then just play around with the dashboard. It is just a quick overview of how the dashboard will look like. Let me just show you that. So it will have the patient analysis details, the medications, a chat interface as I mentioned, where you can come here and ask your questions, and the reports with the total patient that is being analyzed and what are the number of medications and their status. So this is an interactive dashboard that is built in this notebook. And also I have given the agent deployment instruction and the code that is readily available, where we can run it. Cloud run containerizations is something that it is production ready scalability approach that I have chosen, and then where I have coded, and I have given the information here, all the details. And the final step is what I have accomplished from this Kaggle notebook by running all this entire pipeline, and what is the next step, and the helpful resources like a GitHub directory and the questions or the documentations that you can take a look in the GitHub. Now let me quickly get into the UI. So this is a patient dashboard. Now let me load the patient details here. I'm loading the CSV discharge summary file. You would see the preview of the records that is being available in the discharge summary file. And also you could come here and choose the patient that you are interested to do the analysis. Let me load the patient. So you could see the status here. The patient is loaded with the number of medications that is being listed. Let's go to the dashboard. Yeah, follow schedule, drug interaction, current medications, all this has been listed over here with the agent activity log. Let me go to the agent orchestration. You would see the multi-agent orchestration pipeline is readily available here. Let me run it for this patient. Yeah, the analyzer agent is analyzed the diagnosis information and also the medication informations. What is the next step that is being given here for the patient, and the pharmacist agent with all the list of medication that is recommended with a priority, and the care coordinator agent. Let's go to the care coordinator agent. Let's ask like when is my next appointment. Yeah, so it will tell you like when is your next appointment that needs to be scheduled, that you need to talk to the provider and then get it scheduled. So the details are given here, and then the medication review. So this will list all the list of medications for the patients to take post discharge. If there is any allergies, that will be mentioned over here as per the discharge summary. The reports and export. So in this section, as I mentioned before, you could come here and download the summary report of the patient, a medication report, and you can even export the data into the format that you would like to, a JSON or CSV or a PDF format. You could just select and then download it. You could see that in my window it is getting downloaded. Let me quickly show you the image file also. Let me browse the one of the sample discharge summary file. Yeah, let me extract the image data into a text using the Gemini Vision. It will take a few couple of seconds. Yeah, so it is extracted with the JSON format. Let's load this data. Yeah, you could see here the patient is loaded with the medication list. Let's go to the dashboard. You would see the patient details with the follow-up schedule, the current medication list, the timeline, and the agent orchestration. Let's run it. It will have the reasoning with all the diagnosis and medication informations. Same for the pharmacist and the care coordinator agent. Let's go here. Let's ask, for example, what are my medications? Yeah, so it will list you all the medication that you have to take, like how often, how to take, and why, all the details. So again, in the medication review tab, you will have all the medication details with the dosage and the frequency. So you can go to the reports tab to export the data here. Let me quickly show you the last feature that is available in this UI. You can even manually enter the patient here, the patient details. Let's say I'm adding this one, supplementary as a medications. Yeah. Let me load this manual entry. Yeah, you could see the patient is loaded. Let's go to the dashboard. Yeah, so you can see all the patient medication details is given here. Let me run the agent orchestration for this patient as well. So you would see the patient details, medication review, care coordinators, what is my recovery time period. Yeah, see it says what is your conditions and what is your recovery phases and what to expect during the recovery and the success tips. All the details will be given from the care coordinator agent, the medication review and the reports. Yeah, so that's all pretty much that I have in this applications, the agent that I have built. So thanks to Kaggle and Google for giving me opportunity to learn and then do this project. Thank you all. Bye.